So when we hear the word maximum, what is it? What's a good definition for that? Yeah, max. Yeah, the most of something, right? So in this case, we're going to say this is the highest y value. Whenever we're talking about maximums or minimums, we're going to be talking about y values, so up and down on a graph. Okay, so the maximum is the highest y value. So if the maximum is the highest y value, what's the minimum? Lowest y value, right? So lowest y value. So, okay, maximum is the highest y value, minimum is the lowest y value. So a couple other key features that you're going to be asked to identify as part of our last standard that we're having this trimester is an x-intercept. So x-intercepts are the point, or points, I guess, points, where the function crosses the x-axis. So these are the point or points where the function crosses that horizontal axis, okay, the x-axis. Now x-intercepts, there can be several of them in one problem. But in a for y-intercepts, there can only ever be one y-intercept. So the y-intercept is the point where the function crosses the y-axis. Okay, the point where the function crosses the y-axis. So vertical up and down axis. Now, there are a couple other features of functions which we'll talk about, but I think it's easier to talk about it once we see a picture of what a function could look like and then go from there. Okay, so we're going to draw a picture. Your graph doesn't have to be perfect here. I'm just going to draw something that we can use for this. Okay, I'm going to give it some tick marks. You probably want to be doing the same here. I would go out at least 4 in every direction. Okay, just to give us the same working idea that we're going to work from for our graph. One thing about sketching from graphs, right, we don't have to have these be perfect. They need to make sense. We need to be able to see them and understand what's going on, but we don't need them to be like, perfect graphs. Okay. Now, for our function, let's say it looks something like this. It has a dot right here, and then it goes up to this point, and then maybe crosses down to here. Then it goes back up, and then back down. It has an arrow like that. So let's say that this is our function. Okay, it has an arrow on the right side, a dot on the left side. Okay. Now this is a function, because remember yesterday we talked about how a function, the definition of a function is that for each input there is exactly one output, which means if I put in x equals 0, I can get only one answer, right? Or if I put in x equals 5, I can get only one y value. Okay. Now let's make sure that we can identify a few of these key features that we're talking about. Okay. So the first one, let's say maximum. This is usually pretty easy to identify. It's the highest point on the graph. So this point right here, that's our maximum. And its value is 4, because it's 4 up on the graph, right? So again, remember, y values are what we're talking about for maximums and minimums. What is our minimum value on this graph? Gavin? Okay, and where is that going down to?
-4.
Further than that, I think. It's going to negative infinity, right? Why, Jonathan, why is it going to negative infinity? Because of the arrow, right? So Gavin, you're right. On our picture, it stops at -4, but the arrow shows us that our minimum is negative infinity, okay? So it's possible that our maximum or our minimum might be infinity or negative infinity. Okay. We can also probably pretty quickly identify x-intercepts and y-intercepts here. So our x-intercepts, I have two of them. I have an x-intercept right here. That looks to be -3. And then an x-intercept over here of 4. Okay, just those points where it's crossing the x-axis. My y-intercept looks to be right here. So we have a y-intercept of 2, right? Because it's up 2 on the y-axis. Now those are kind of the basics that we've covered so far in our graph, in our key features of functions. Okay, we have 2 more that we want to talk about, actually 3 more that we'll talk about. The first 2 are intervals that where the graph is increasing or decreasing. Okay, so before we do this, one thing that I think is helpful for figuring out intervals is to draw dotted lines back to the x-axis wherever the graph changes direction. So I'll show you what I mean by that. But like right here, I'm going to draw a dotted line up to there. And then I'm going up in my graph, it's increasing, and then it changes direction. So right where it changes direction, I'm going to draw a dotted line back to my graph, and we're going to say it hits over there at 1. Okay? And then again, I'm going to follow this until it changes direction, which is right about here. And then I'm going to follow it again until it changes direction, which is right there. Okay? And everywhere that I see it change direction, I'm just drawing a dotted line back to the x-axis. Okay, now I'll show you why we're doing that here in a moment. It's just to help us make sense of the intervals a little bit. Okay. When we're asked to identify intervals of increasing on the graph, okay, I am increasing or going up on this graph from this value, -4, to this value, -1. Okay? And when I write these intervals, they are x values. So -4 and -1 are x values. But my graph is increasing in the y direction, right? So I'm increasing going up from -4 to -1. Yeah. And then another interval that I'm increasing on is from this point, right? Because I was going down all the way right here. Looks like I'm increasing from 2 to 3. Okay, I'm just increasing over that short little interval right there, from 2 to 3, where it goes back up again. Okay, so it's going from this point up to that point, so from 2 to 3. Okay. Mm-hmm. So remember, 2 and 3 are x values. So here's 2 on the x direction, and here's 3. So between from 2 to 3, it's going up. Yeah. Okay. So intervals of decreasing are from -1 to +2. Okay. Because I'm going down from this value, -1, right here, to 2 right here. I'm decreasing over that interval of time. Okay. And my last decreasing interval is from 3 to +infinity. Because from 3 to infinity this way, forever going forward, the function is going down. Okay? Now, those ideas of increasing and decreasing are going to take some time for us to wrap our brains around, right? But we need to start getting used to them. We're going to explore them a little bit today as well as we go through. Okay? Last thing I want to talk about is domain. Okay? Before we say anything about the actual domain of this function, is this function discrete or continuous? Class, let me have everybody's attention up here. Is this function discrete or continuous? Continuous, right? It's a connected curve. So it's continuous. So all continuous functions have what domain? all real numbers, and then we need to specify which numbers we're looking at. So in this case, I'm looking at all real numbers greater than or equal to -4, because that's where it started, right? I don't have an arrow going to the left, I have a dot. So because of that dot, I'm going to say greater than or equal to -4. Okay, because from here, all the way this way forever is part of my domain. Okay? Now, we're going to keep talking about domain. We're going to keep bringing it up over and over again for a long time because it's one of the key ideas that we have from this trimester that we need to keep working on. Okay? All right. Now, I know that's a lot. We need to get into our next part of what we're doing here. Okay? So, you will probably, well, pay attention to this and we'll talk it out real quick. Okay? So, it says Alonzo and Maria and Sierra were floating in inner tubes down a river, enjoying their day. Alonzo noticed that sometimes the water level was higher in some places than in others. Maria noticed that there were times they seemed to be moving faster than at other times. Sierra laughed and said, "Math is everywhere." To learn more about the river, Alonzo and Maria collected data throughout the trip. Okay, so here's their data. So let's make sense of this. It's just a chart. It's just a table. On the top here, this time in minutes, these are our x values. The depth of the water in feet are our y values. Okay? There's just a line right here down the middle. So if we make sense of what this chart is saying, it's saying that at 0 time, the water is 4 feet deep. Okay? And at 10 minutes, the water is 6 feet deep. At 20 minutes, it's 8 feet deep, and so on. Okay? Does that make sense? What you are going to do is you are going to use the data collected by Alonzo to interpret key features of this relationship. I want you to find 4 things in your group. I want you to find the max, the min, okay, intervals of increasing and decreasing. Now, one thing that I think has helped both the first hour and second hour quite a bit is if you take this table and make a graph out of it, it might be a lot easier to see where those intervals of increasing and decreasing are. Okay? You don't need to, but that might be a good suggestion for you. Okay? We're going to give you approximately 5 or 6 minutes. We should hear lots of conversation during this time frame. It's group work right now. Okay? So let's get started. Okay? 5 or 6 minutes and we'll bring it back together. If I'm looking at this table, and one thing that I might do if I were doing this, because maybe I don't want to make a new graph, and I have this table, I might even just kind of sketch what's going on the table, just to kind of give myself an idea. So I know down here it's like at 4, and I'm just going to say that's right here. And it's increasing 6, 8, 10, it's down to 6, 5, 4, 4, 5, 7, it goes up to 12, down to 9, 6.55. Right? This is kind of what's going on. Now, it's not perfect. It's just an example of what's going on. I can see that I have a maximum right here at 12. Right? So there's my maximum. I can see that I have a minimum over here at 4. So my minimum is 4. Okay? For my intervals of decreasing and increasing, I mentioned this. I think they're easier to see from the graph that we looked at. But our increasing intervals go from 0 to 30, and then from 60 to 90. Because if we look at this, see how my y values are increasing as I go from 0 to 30, and then they start decreasing until I get to 60, and then they're increasing again until I get to 90, and then decreasing again until I get to 120. So my decreasing intervals are 30 to 60, and then 90 to 120. Okay? Now, again, we're getting used to these ideas of increasing and decreasing. Okay? The thing that I think is trickiest about it is that increasing and decreasing are x values, but we have to write them based on what the y values are doing. Okay? That's probably the trickiest thing about that. Okay? Let's look at one more scenario before we pack up and start getting going for today. Okay, so Maria created a graph by collecting some data from GPS data about how far they had traveled. So now we're no longer looking at the depth of the river, we're looking at the distance that they've traveled down the river. Okay, so using this graph that she created, right? So time that they traveled is on bottom, 10 minutes, 20 minutes, 30 minutes, and so on. Distance that they've traveled down the river is here on the y values. Using this graph, okay, so in a minute, you're going to want to sketch a copy of this graph. It does not have to be perfect. It doesn't have to have all the values in here. Just sketch a copy of this graph, and then you're going to, as a group, answer these questions. You're going to identify these key features. Where it's increasing, where it's decreasing, the domain, the maximum, the minimum, and the x and y intercepts. So that is 7 things. Okay? Increasing, decreasing, domain, max, min, x, and y intercepts. Okay? So as a group, I want you to look at this graph, identify those 7 things. Okay? And then we'll talk about it briefly in about 5 minutes. Okay? So 5 minutes, ready to go. Are going to be maximum, minimum, x-intercepts, and y-intercept. Okay? What is the maximum distance traveled? Gavin?
16,000.
16,000 feet. Almost probably close to 5 miles, right? What is the minimum distance traveled? 0 feet, right? Before they started, they had gone 0 feet. Okay? What is the x-intercept of this function? 0, right? Way back here, where it crosses the x-axis is 0. What is the y-intercept of this function? Also 0. So now let's talk about the ones that take a little bit more thought process here. Where is this function increasing? What interval is it increasing on? 0 to 120, right? In fact, it's increasing the whole time, right? This makes sense. We're floating down a river, so our distance is always going to be increasing, right? It's pretty hard on a river to suddenly not be floating down the river or to suddenly be floating backwards on the river, right? That's hard to do, okay? The key word there is floating, right? You can't really float up a river, okay? What about intervals of decreasing? Are there any intervals of decreasing? No, so there are none. So this is good to know that sometimes we don't have that key feature. Sometimes it doesn't exist. What is our domain here? Perfect. Oops, I don't know why I wrote down. Domain is all real numbers from 0 to 120. Okay? Because what type of... Wait, hold on. I'll give you time here. Okay? Is this function continuous or discrete? Continuous, right? So whenever we have a continuous function, it will always be all real numbers. It's just a matter of what our interval is, right? From 0 to 120 in this case. Okay? Now, like I said, we'll stop here. We will pick this back up tomorrow and finish tomorrow. Please clean up your area. Calculators need to be put away. Okay?